Okay, for the first one, well, how do we start it out? First, of course, we've got to write out the equation or the expression. What's that going to look like? Perfect. X plus 3 is in parentheses, and that times 6 equals 48, because it is 6 times the sum. The sum is the result of an addition problem, so that implies the addition was done first. So we have to have the parentheses. So now we're going to multiply through the 6. 6 times x is 6x. And 6 times 3 is 18. And then subtract 18. 6x equals 30. And then divide by 6. X equals 5. How many of you had x equals 5 for the first one? Perfect. How many of you got an answer for the second one? Okay, well, let's take a peek. We draw the rectangle, we have the width, and we have the length. We also have a formula that perimeter is 2 times the length plus 2 times the width. This tells us that the length is 7 more than the width. So it gives us a relationship between them. Remember, whenever we have 2 or more variables, we have to somehow reduce that down to 1 by coming up with relationships between the variables. So we can define one variable in terms of the other, or one variable referencing the other. So if the length is 7 more than the width, I'm going to place in here that the length is the width plus 7. So now in this formula here, P is going to be 2 times, instead of L, I'm going to put in W plus 7, width plus 7, plus 2 times W. Now, is there anything else I can replace in that formula?
P.
Perimeter is 82, so I'm going to replace P with 82. So 82 is equal to 2 times W plus 7, plus 2W. And now on the right side there, I'm going to simplify whatever I can. The 82 on the left will stay the same. 2 times W, 2W, and 2 times 7, positive 14. And of course, we still have this other 2W over here. Then what? We can combine them. 2W and 2W makes 4W. We still have the plus 14 here. Subtract 14. Very good. 68 equals 4W, and then divide by 4. So 17 equals W. Are we done?
No.
No. Come up here, W equals 17. The length is W plus 7. So 17 plus 7 is 24 is the length. So when we left off last class, which was almost 2 weeks ago now, 12 days ago, we had just started doing some problems like this, if I remember right. We had taken the words and put them into equations and formulas, and we had just touched on some of these problems. Is that correct? Sound about right? So it probably wouldn't hurt to review a few of these. Let's try this. The length of a rectangle is 4 times the width. If the perimeter is 210, find the length and the width. I'm going to give you guys a second, see if you can set that up. Very similar to the one we just did, but slight difference. Okay, now I'm a visual person, so I always draw out a picture. And then we'll put down our formula. Perimeter is 2 times the length plus 2 times the width. Now, is there a relation? What relationships can we fill in here? Length equals 4 times the width, or 4W. Okay, anything else? Perimeter is 210. So we're going to rewrite our equation here. 210 is going to go in for P. And then for L, instead of 2 times L, it's going to be 2 times 4W. We still have the plus 2W out there. So now we're going to combine. 2 times 4W becomes 8W. And then we have 8W plus 2W is 10W. So we divide by 10. 21 equals W. And of course, we're not done yet. We got to go back up here. W is 21. The length is 4 times 21, or 84.
I have a question.
Yes.
For when you start out and you went from 2L plus 2W,
Yep.
why wouldn't you keep that the same and put the 1, 2W in parentheses and then put the 4 outside of it? It doesn't really matter. It doesn't change what you get for an outcome. I'm just,
Well, the 4W goes in the parentheses. It's what replaces the L.
but it says 4 times. So I'm just make,
L is equal to 4 times the length. So L is equal to 4W.
will that always work if I put the 2L in the parentheses and then put whatever it's times on the outside? Will that always
Not necessarily, no.
So I should, if it says 4 times or something like that, always put that in the parentheses?
Yes. Yes.
Okay.
Because there are times when that will not work.
Okay, I just wanted to make sure, because I did it slightly different.
For example, like in this one. The length of a rectangle is 3 more than twice the width. The perimeter is 126. Find the length and the width. See, now here, if you tried to do that, that will not work out. No. See, we got the, well, you could if you want to work through it, it will come out, but it's not, you got to be very, very careful. There's a lot of ways that could go wrong in it. But we do have that the length is 3 more than, so 3 is added to something, but it's not W plus 3, it's twice the width, so 2W plus 3. So over here, P is still going to be replaced with 126. But this is 2 times L, it's going to be 2 times 2W plus 3. Plus 2W. So 126 equals 2 times 2W is 4W. 2 times 3 is 6. Still plus our 2W. Now what? Four W and 2W makes 6W plus 6. And then minus 6. 120 equals 6W. And then divide by 6. Very good. 20 equals W. W equals 20. L is 2 times W, or 2 times 20 plus 3, which is 43. Now, the other common mistake people make is they don't write this down. You'll notice I always write out L equals 2W plus 3, or L equals 4W, or whatever it happens to be. I always write that out. Because once I solve my equation and I find what W is, or X is, or whatever, I still have to go back and answer the question. And if I don't have this written out, I have to remember, okay, what did I define X to be, or what did I define L to be, or whatever. So I have to, by writing this out, now that I know that W is 20, I can just look at this and say, oh, I've got to do 2 times 20 plus 3, and I have the length, and I'm done. So that little bit of effort up front does save a lot of mistakes and confusion later on. Well, the next thing we're going to look at is mixture problems. And I think we started on these maybe a little bit last Wednesday. I don't remember for sure, but if we didn't, that's okay. We'll start from scratch again today. It's one of those topics that's difficult enough that it's okay to spend the extra time on them anyway. When we talk about mixtures, usually a mixture contains one active substance and one inert substance. For example, solutions are a type of mixture. You have salt water. The active substance there would be the salt, the inert substance would be the water. The water is just the carrier, the filler, that makes the volume go up. In metals and in other things, we have a lot of solutions that we use. Metals, we have alloys where you mix alloys or whatever. But there are a lot of times that you want to adjust the concentration of a solution. So or of a mixture. The major mathematical formula that governs a mixture is the amount of the active substance is equal to the concentration times the total volume. So now when I say that a solution is a 24% solution or a 24% mixture or whatever, what that means is that 24% of the total volume is the active substance. And it's that active substance that we're really interested in. So I'm going to say we have a 16% mixture, 16% solution. We're saying 16% of the solution is our substance that we're interested in. So let's say that we have 400 milliliters of a 41% solution. How much of the substance do we have? Well, the amount is what we're looking for. 41%. Now the concentration is the percent as a decimal. So 41% is 0.41 times the 400 milliliters. So what is that, 164 milliliters? So in that 400 milliliter mixture, 164 milliliters of it is the active substance because it's 41%. The other side of that is, let's say we have 16% mixture and need 368 milliliters of the substance. How much of the mixture do we need? So in this case, we need 368 milliliters of the substance. We need 368 milliliters as our amount of the active substance. Our concentration is 16%, and we are looking for the total amount, the total volume. So to solve this, we're going to divide by 0.16. Oops, I don't know where that 63 came from. That is 68, isn't it? 368. So 368 divided by 0.16 is what? 2,300 milliliters. So it would take 2,300 milliliters of that mixture to give us 368 milliliters of the active substance. What we're more concerned with is combining two of those mixtures. So let's say we are going to combine 300 milliliters of the 27% solution with 200 milliliters of 42% solution. Find the final concentration. Pretend you can read that word. Sorry, my handwriting's horrible today for some reason. Anyway, so what I have is I'm going to add one mixture plus the other mixture to get a final mixture. Well, my first one is 27%, and I have 300 milliliters of that. My second one is 42%, and I have 200 milliliters of that. Over here, I don't know the percent. That's what I'm looking for. Do I know how much of it I'm going to have? Where'd the 500 milliliters come from? Yeah, I combine 300 with 200, I'm going to have 500. So to write out my formula here, the amount of substance in this first one is 0.27 times 300 milliliters. How about for the second substance? 0.42 plus 200 equals, this will be x times 500. So now 0.27 times 300 is 84? I think it's 84. 0.42 times 200 is also 84, isn't it? Yes, it is. That's convenient. Then x times 500 is just 500x. Is it 81 instead? Okay. There. So now I've got 81 and 84 make 165 equals 500x. And we proceed to divide by 500. Which is what? 0.33? Is that correct? .326? Something went wrong there. 0.33 should be. Okay. So what do you think? That wasn't so bad. We did one of I know we did at least one of those before you left, before break, didn't we? I think so. Let's have you guys try one. So we're going to mix, we're going to combine 150 milliliters of 40% solution with 250 milliliters of 64% solution. Find the final concentration. So we'll pause and let you guys try that one. So we're looking at combining a 40% mixture and a 64% mixture to get a new mixture that we need to figure out what the concentration is. So the 40% mixture is 0.4 or 0.40 times what? 150 plus 0.64 times 250 equals x times 400. And yeah, we will change that to 400x in a little bit. So 0.4 times 150, otherwise known as 60. 0.64 times 250, 160. And then, of course, 400x. Yes?
So just because of math, simple things actually matter sometimes.
Yep.
Does it matter where you put the x in the 400?
As long as they're on one side of the equal sign by themselves, x times 400 or 400 times x doesn't make a difference.
Okay, I just wanted to make sure.
And you notice I always switch it in the second step too. The only reason I put it this way in the first step is because I am used to having concentration times volume.
Okay.
So I put it that way just so it's represented that way, so you know that that x is a concentration, and that's the only reason I put it that way.
Okay.
So now here 160 and 60 make 220 equals 400x, and then not everybody at once. What's next? Divide by 400, perfect. So 0.55 equals x, so that is a 55%. How many of you had 55%? Not at first, you do now. Does everybody see how to get the 55%? Anybody have questions in the process there? Okay. Now we're going to change it up a little bit. Can't stop while it's still making sense, can I? We have 58% solution and 70% solution. Now I'm going to do this one for you. We need 66% solution. So here's our question. How much 70% solution to mix with 240 milliliters of the 58% to get to the 66% solution? So we are mixing 58% and 70% to get to 66%. So the 58% is 0.58. Do we know its volume? 240. 70% is 0.7 or 0.70. Do we know its volume?
No.
No, in fact, how much of the 70%? So that's what we're looking for. So we'll call that x. Equals 66% is 0.66. Its volume is,
I don't know.
somebody said there, 240 plus x. Because up here, it was 150 plus 250 made 400. Same thing down here. 240 plus x makes 240 plus x. I am going to write it though as x plus 240 just because we're used to having the variable first. So now 0.58 times 240 is, this one's going to get ugly. The number, you got it narrowed down. $139.2. 0.7x is just 0.7x. Over here we've got 0.66 times x is 0.66x, but we also have to do 0.66 times 240. 158.4. It was a long Thanksgiving break.
I'm kind of surprised.
I've been, all day I've been like basically, did we cover this before break? Are you sure? I don't have a clue where each of my groups were. I teach 4 versions of this class. I don't remember which class was where anymore. Well, you're actually, because of your 2-day-a-week schedule, all the other classes meet 3 days a week for 1 hour. And I've happened to miss a couple of Wednesdays, which is your 2-hour class. So you guys are a couple hours behind. No problem. Nothing serious. So now we have to solve this. We have an x on each side, so I got to get rid of one of them. So I'm going to get rid of the smaller one, the 0.66x. So now this is 139.2 plus 0.04x equals 158.4. And then subtract 139.2. So 0.04x equals, anybody? 19.8, correct? That's where you're going with it? That's not correct though, it's 19.2. Does that look better now? Sure. It actually is right this time. So then we divide by 0.04x, or just 0.04. Which will give us what?
480.
It is 480 milliliters.
But we're not done?
Are we done? X is the amount of the 70%. Is that what we were asked for? Yep. So 480 milliliters.
So we don't have to find what the total was.
Nope. They just want to know how much of the 70% to mix in.
Oh,
Are we gonna have like this one like this in the test?
Possibly.
that's a yes. This one we do on our own?
Yep.
Well, my parents always said possibly meant no,
I'm not your parents. Let's see, we have 19% solution and 35%. We need 31%. So our question, how much 35% to mix with 135 milliliters of the 19% to get our desired 31%. Give that one a shot. Okay, so we're going to mix 19%. Okay, I'll give you a second. Okay. Okay, so 19% is 0.19 times, do we know how much?
135.
135. Plus 35% is 0.35 times x. Very good. Equals 31% is 0.31 times, perfect, x plus 135. So 0.19 times 135 is what? 25.65. That's what I thought. Of course, that's 0.35x. 0.31 times x is 0.31x. 0.31 times 135 is 41.85. Okay, so what do we do from here? We get rid of one of the x's. The smaller one's the 0.31. So 25.65 plus, this is once again 0.04. X equals 41.85. And then minus the 25.65. Yeah, 0.04. X equals 16.2. And then divide by 0.04. Gives the x equals what? Is that 405? Sounds good to me. 405 milliliters. What do you think? Good stuff? Now, there won't be a test till the second hour on Wednesday. What's that? 2 hours is on Wednesday. 1 hour today. No, we're good with that. There will be a couple of those on the unit test, but not a lot. Yeah, on Wednesday, yeah. What that'll do is that'll give us then 2 days basically. It'll give us Monday and Wednesday of next week to do a little bit of geometry. And then the final week we have 3 hours of class. That'll be your final test during those 3 hours. We'll take all 3 hours to do it.
What's the final test? It's not gonna be everything down.
That's everything you've done since the beginning of the semester. It's only 37 pages, so it's nothing to worry about.
It's just one question per subject.
Just 37 pages. It's not near as bad as it sounds. Trust me. Scary words from a math teacher. Trust me. Give me a couple minutes and I'll look it up for you. So anyway, let's take a look at maybe a slightly more difficult version of these. Let's say that we have 42% and 57%. We need 600 milliliters of 52%. How much of each do we need to mix? So here we have 42% and 57% that we are combining to make 52%. But here's the catch. We know the 52% is 600 milliliters. We know the volume over here. In all of our other problems, we've added together the other two volumes to get that one. So now over here we have the 42%. We have the 57%. Do we know how much of either one?
No.
No, we're looking for both. But we don't want to have two variables here. But let's say if I know I'm going to use X milliliters of 57%, how much of the 42% am I going to need? Yeah, this plus that has to equal 600, right? So if I know one, how do I find the other? I subtract it from 600. 600 minus X. It's just like if I give you $10 and you're going to buy two items for $10. If you know, once you find out the first one is $2, the second one has to be 8. It's 10 minus 2.
Does it matter which one you do that?
You could put the X here and 600 minus X over here. It's just going to give you, you got to remember which one is X then. Here now we have to remember that X defines the amount of the 57%. So now 0.42 times 600 is 252. Is that correct? 0.42 times negative X is a negative 0.42X. Does that work out right? Plus 0.57X equals 0.52 times 600 is what? 312. Now I combine. Here's the reason, by the way, that I made the X be the higher percent. If I made the X be the lower percent, I'm going to get a negative here. Since I made the X the higher percent, now I'm going to get positive. Negative 0.42 and a positive 0.57 make a positive 0.15X. So there are reasons why I do things. It would have worked out the other way. We just would have had negative numbers to deal with. So now we're going to subtract 252 from both sides. So 0.15X equals 60. And then we divide by 0.15, that X equals 400. What was X again?
400.
X was the amount of the 57%. 57% is 400 milliliters. The other one is 600 minus X. 600 minus 400 is 200 milliliters. That would probably be a step beyond what I would ask you on a test, but just be aware it can be done. Okay, we just have a few minutes left, so we don't really have time for you to try one of those. But in your book, on page 264. Exercise 6.6, 1 through 25, the odds. And just in case I didn't assign this one to you before break, I'm going to put it on here, page 260, exercise 6.5, also 1 through 25, the odds. As I said, on Wednesday in the first hour, we got some new topics we'll cover. We'll spend a little time reviewing as well, and you'll have the second hour to do your test.